Hey everyone, this is 8.4 annuities. Annuities are essentially like savings accounts, except that instead of putting in a lump sum amount that you earn interest on over time, you're going to be making regular monthly payments into an account, and then you're going to earn interest over time based on how many payments you put in there, and also how much interest you've already earned on those payments that are in there. We're going to focus specifically on what are called ordinary annuities, and this just means that one payment is made into the account at the end of each month. Um, as kind of like a little side note, if you check out the TVM solver, which we'll talk about in a second, at the very bottom of the TVM solver screen, there's like a little option that says menu, or sorry, it says payment, and you can change it to end or begin. If you have it on end, that is specifically for the ordinary annuities. So we're going to try to illustrate what's going on with annuities with a basic little example here where we're assuming we have some annuity and we're making $100 monthly payments into the account, which earns 12% interest from January to June. And the question is, how much money will be in the account on July 1st? Okay, ignore this one real quick. So we have these, we're putting $100 into the account at the end of each month, and we're starting on January, so here's our first $100. And notice if we're gonna take our money out on July 1st, that first $100 will be in there for all of February, all of March, all of April, May, and June. And so that's 1, 2, 3, 4, 5 months that $100 will be in there or earning monthly interest. But not only that, on the second month, at the end of February, we're putting in another $100, which will be in there for all of March, April, May, and June, another 4 months it's earning interest. And then the $100 payment on March will earn 3 months, etc., etc. Notice our very last payment at the end of June, it actually won't earn any interest because we're going to take it out on July 1st. One way you can actually calculate this, which is tedious, is to do it month by month. This first $100, we could calculate how much interest that's going to earn by plugging that in for P, and then plugging in our monthly interest rate, or sorry, annual interest rate, which was 12% or 0.12, divided by 12 because we're compounding monthly because we're making monthly payments. And we're plugging in 5 because, like we said, this is going to be in there for 5 months. Well, then the second $100 would be in there for 4 months, and the next one will be in there for 3 months, etc., all the way down to the very last one, which should actually only be in there for 1 month. So this whole piece here, when you raise it to the 0 power, just becomes 1. So you actually just get 100. So you can kind of picture this by just taking every single month, or sorry, every single payment, and tracking how much interest and how much interest and money you'll get just out of each payment. And then obviously you would add all these together to tell you how much is going to be in the account at the end. Well, we're not going to be doing it one by one, but this is just kind of showing you what's happening. We're going to have kind of a big formula that will wrap this all together. So here is that formula. It's called the future value of an annuity. It is A equals capital R, which is our new variable here, stands for the monthly payment. So capital R times this whole fraction. Notice the way I wrote it is the R is right next to the fraction bar because the R is not in the numerator or the denominator. If you calculate this by hand, I recommend you calculate the entire fraction, get an answer, and then multiply that by R at the end. The good news is all these other pieces inside the formula we already know. R, M, N, these are the same things from 8.2, the compound interest, future value compound interest formula. Here, N is the number of payments. Pretty much with annuities, we're always going to be making monthly payments into the annuities, so that means our interest will always be compounded monthly. That actually means M is always going to be 12, right? And then N, it will just end up being the number of months, which is the same thing as the number of payments. So for that last example, we would actually throw it into the formula here instead of doing all of those 6 pieces and adding them together. So here's our capital R, right, because we're making monthly payments, annual interest rate, the 0.12s, 12 and 12 because we're compounding monthly, 6 because there's going to be a total of 6 payments in there actually. And then don't forget this -1 from the formula. This whole formula kind of makes sense from a more complicated formula. It's kind of more information than you need. But basically, when you add up a series of things like something to the first, something to the second, something to the third, etc., you can actually simplify it into a formula that looks a lot like this. In this case, if you calculate all this, notice here I calculated the fraction part, got a decimal, and then I multiplied it by the 100 right there, and I got $615.20. This is not only the $600 that you actually put into the account, right, because for 6 months you put $100 payments in there. You're actually getting all the interest that you're getting out of each, basically for each month for the amount of money that's already in there, right? So all the money and all the interest that you'll get out of the account under those conditions we discussed previously. So this is how you do it by hand. You can also use the TVM solver, because anytime you're dealing with compound interest, you can use that TVM solver function. Don't forget to check out the I have a TVM solver example video next to the video lectures for chapter 8 that'll give you some more examples of how to do that with the actual calculator. Alright, so we're going to do a problem on page 414. Notice in the italics here it says assume the compounding is being done monthly. So this is number 29. Matt is saving to buy a new Vespa if he deposits $75 at the end of each month into an ordinary annuity that has annual interest of 6.5%. How much will he have saved in 30 months? So this is kind of straightforward solving for A, the future value. We're going to use our annuity formula. Don't forget the -1 here on the top. A lot of people forget that. And we're going to plug in each piece we have. R is the monthly payment, which is 75. Little r is 6.5%, so that's going to be 0.065 as a decimal, divided by 12 because we are compounding monthly. N is the number of monthly payments, or the number of months. They're telling us it's 30 months, so it's just going to be 30. And then -1. And then another 0.065 over 2 in the denominator. So just like last time, I recommend you calculate the fraction part first, get an answer, and then multiply that by the 75. If you do that in this problem, you should get, this should be a 12 here. You should get 75 times about 32.4799, we'll call it. And then when you multiply that by 75, you get a final answer of about 2435.99. That is rounded to the nearest cents, and that is in money. Right, so in this case, he's putting $75 in the account each month for 30 months, so that's 75 times 30, and then also he's getting all this interest for being compounded monthly at 6.5%. So that's just kind of the straightforward, given all the pieces, plug it in, solve for A. In the TVM solver for this problem, by the way, here's all our values, the N, I, PV, etc. N is 30 because it's 30 months. I%, don't forget you always put the actual percent in there, don't convert it to a decimal. So we're given 6.5%, so we plug in 6.5. PV, notice there is no present value, there's no P in these problems, so make sure that's set to 0. Your payment is $75. I usually put in the payment as negative because you're losing it when you pay it. Future value is what you're solving for, so once you get the rest plugged in, P over Y, C over Y are 12 because they're compounded monthly. So once you get all that plugged in, you go back to future value, you press alpha and then enter to solve, and it should give you that value, 2435.99, which is what we got the other way too, so this is probably the quickest way to get to your answer. Alright, we also have this idea of what's called a sinking fund. This really isn't a new thing, it's the same exact formula. It's just that a sinking fund is an annuity with a target future amount. What I mean by that is you know how much you want in the future. The question is what kind of monthly payment should you be paying right now in order to get that in the future. So given in the formula, given A, the future value, what is R, the monthly payment? Right, so on page 414, number 39, it says Kanye wants to save $14,000 in 8 years by making monthly payments into an ordinary annuity for a down payment on a condo at the shore. If the annuity pays 0.7% monthly interest, what will his monthly payment be? So notice they don't say sinking fund here, but he wants to have 14,000 in the future. The question is, what is his monthly payment? Sometimes they call it a sinking fund, sometimes they don't. Just be aware, if you see sinking fund, just think annuity, and it's usually an annuity where you know A, but you want R. So let's start out with our formula. And one kind of weird thing about this problem is that we're given 0.7% monthly interest. This is weird, and I don't really know why they specify monthly interest sometimes on these annuity problems, but this is kind of the only section where you see it. Remember, you have to be careful about your units of time with your interest. In fact, in this formula, you divide your R, which is usually annual interest, so it's a bad looking R over M, and R is usually your annual interest, and in this case we're dividing by M, which is 12. Well, if you take something that's yearly and divide it by 12, you make it monthly. So the trick here is that since they're already giving us monthly interest, it's already been divided by 12. So you actually don't want to plug in 0.7 or 0.007 over 12. 0.007, this is a, sorry, that's a percent. This is a percent, so it should be 0.007 as a decimal. That is a monthly interest rate, so it's already been divided by 12. So in the formula, we can actually just use 0.007. So that's kind of a weird catch, a weird detail you have to pay attention to when they give you a monthly interest. The other problem with that is on the TVM solver only takes in yearly interest. So what this means is on the TVM solver, you're going to have to take that 0.7 actually, multiply by 12, and that's what you're going to enter into the I%. So it's really kind of an annoying little detail that pops up in this section only, but keep in mind, if you have 0.7 or if you have any type of monthly interest, you're going to have to be careful about how you enter it. So for this problem, we have A, it's 14,000, that's how much we want in the future. We're trying to figure out what capital R, our monthly payment, is. In the numerator, just cordon that off, we have 1 plus, now like I said, R over M is basically turning your annual interest rate into a monthly interest. They gave us monthly interest, so we're just going to plug that in. As a decimal, of course, 0.007. And then 8 years, we're going to do this monthly for 8 years, so that would be 8 times 12 up here. 12 months in a year for 8 years. Don't forget your minus 1, and on the bottom it's R over M again, which is monthly interest, which we already have. Alright, so we can clean this up a little bit. Obviously this is 1.007. 8 times 12 should be 96 minus 1. We have another 0.007. And then from this step, we want to solve for R. So this whole fraction here, let me show you. This whole fraction here is just some number. So if we want to get R by itself, we're going to divide both sides by this number. It's pretty rough to write out, but these are technically the steps you would do by hand. So we're dividing it over on this side, so it cancels out. And then over here we would divide it as well, and this will be our the answer that we get. So 1.007 to the 96 minus 1. Alright, so R equals whatever you get out of that. Again, I wouldn't recommend you do any of this work by hand. I recommend you actually plug it into about this point and then use the TVM solver. That way, once you plug it in at this point, you'll have all the pieces on the paper, and I'll be able to give you partial credit just in case you mess something up later. But the TVM solver is really the best, most accurate way to get an answer on the calculator. I really recommend you use it. But I want you to give me something on paper, that way I can give you partial credit. So I usually tell students, write down the formula, plug in all the pieces, then jump to the TVM solver to get your answer. If you do it this way, you definitely can get the right answer, but it's tricky to plug all of this into the calculator and not mess up a parenthesis or something like that. So if you do it the long way, I recommend doing this fraction separately, this piece down here, getting like a decimal to a bunch of decimal places, and then go through it, go back in and take your 14,000 divided by whatever that decimal is. So in this case, if you were to do that, I'll give you an answer. This was 39, sorry. You should get, there we go, a monthly payment of about 102.78. So R will end up being $102.78. Right, so if Kanye wants to have $14,000 in 8 years, which is 96 months, he's going to have to put down $102.78 for all 8 years with this 0.7% monthly interest. Okay, lastly, we're going to do one problem here on page 415, number 49. It says, assume monthly deposits are being placed into an ordinary annuity. Interest is compounded monthly, all the kind of normal stuff we would assume. This one says we have some Reliance Volunteer Fire Company. They want to take advantage of some program to buy a new truck. Truck will cost $400,000, and members of some finance committee say they can save $5,000 per month in an ordinary annuity, paying 10.8% annual interest. Right, so they gave us a monthly payment, they gave us an interest rate, they also gave us a future value of the $400,000. The question is, how long will it take to save for the truck? So for this question, they're asking us for time, which is N. So either way, it's obviously an ordinary annuity, so let's start with our formula. Keep in mind, anytime you solve for N, sorry, M over N, so R over M, there we go. Anytime you solve for N, you're going to have to use logarithms. Also, let me remind you that I recommend you don't do that because I think you should just use the TVM solver, but I want to show you how to do it by hand just so you know. So let's plug in. We know we want 400,000 in the future. Oops, we know what R is this time though. It says we can save monthly payments of 5,000 per month. It's a big monthly payment. We know our annual interest rate is 10.8%, so that's 0.108 compounded monthly. N is what we're after. Right, so this is the setup. This is where I would stop and throw everything into the TVM solver. But I do want to show you, just so you know how, and just so you can work it out on paper if you need to, how to do this by hand. So what we're going to do is we're going to try to isolate the piece with the N in it. So a couple things we can do is we can multiply both sides by this denominator. So this is, I'm going to warn you ahead of time, it's going to take some work, but bear with me. We're going to multiply both sides by the 0.108 over 12. Right, so it cancels out here. On the other side, 0.108 over 12 times the 400,000 will give us 3,600. I'm going to put this in brackets real quick because you got to remember that that 5,000 is not actually in the numerator. Alright, so we got rid of our denominator. Next thing we need to do is get rid of this 5,000. So we're going to divide both sides by 5,000. Oops. It's going to cancel out here. Over here I'm going to cancel out 2 zeros just so we can deal with smaller numbers, 36 over 50. So let me zoom out again. So we've got 36 over 50 equals, did I simplify that? Yeah, the if you plug in 0.108 over 12 and add 1 to it, you should get 1.009 to the n minus 1. Lastly, if we want to get this piece by itself, we have to add 1 to both sides. Right, so we get, one more time, well maybe not one more time, we'll see. We'll get 36 over 50 plus 1 equals 1.009 to the n. This is the point where we can use a logarithm to get that n down out of the exponent. So we are going to take a logarithm of both sides. Actually, move this over. So we're going to take log of this side and log of this side. And remember, the whole point of this is we're using that exponent property of log to take this in and pull it down in front of this log. So our next line will be log of this number, whatever it is, equals n times log of 1.009. Right, so our n, our variable, came down out of the exponent. So now all we have to do is just get n by itself, which means we're going to divide by this log, which is just some number. They cancel out here, and if you throw these two logs in your calculator and divide them, you should get something like 60.53. Now, the question, if you don't remember, was how long will it take to save for the truck? Since we're compounding monthly, n is automatically in months. So this is 60.53 months. And so if you want to answer in whole months, by the 61st month, right? So we'll just say 61 months. Oops. Right, in 61 months, they will have saved enough. $400,000 actually will have saved a little bit more. And that is it for this problem. So notice, like I said, when you're solving for n, you're going to have to use logs, and that usually involves a lot of kind of tedious little algebra here. So I personally would have been happy stopping right back here. Right, as soon as you show me the formula we're using, plug in all the pieces to that formula so that I know that you know what each piece stands for and where it goes. Then you can jump to the TVM solver, plug all these pieces in, and that should help you get right here to the answer, the 60.53, which rounds to 61 months. So that's it for annuities. I hope this helps. Let me know if you have any questions, and keep up the good work.